Hey guys, welcome to Heart Academy for Monday, October 16, 2017. And today's lesson is quite different, almost a distance learning type of thing. Though I am in the building, I have lots of things to do. I need to reorganize our classroom structure and our classroom in general. So you'll be doing your work on your own. And Mr. Weimer's room, which I think is the computer lab. So what we're going to do is complete the packet together, and you'll complete the packet and using these videos and the packets that I already given you, and you don't have to worry about reading it because I'm right here. I'm going to read it for you, so you need to follow along with your packet and also your question packet, and everything should go smoothly. Watch the video in its entirety, all the videos, because there's probably more than one posted, because I'll be telling you what you need to do for the entire class time so that you have no questions, okay? By now you should have received a checklist that looks like this. Right? The checklist has everything on it that you need to do and what you need to bring to class. And then also you need to make sure that you have your packet, your reading packet, which is this, and also the question packet that we had begun last week. The question packet is, this question packet. Okay, now the thing with the question packet is that page 13 is not there. So page 13 you will get from Mr. Weimer, and which is this page 13 is not actually in the pack that I gave you last week. So you just need to take that extra page from Mr. Weimer and staple it to this entire packet so you have all the pages. Doesn't matter if it's in order or not, staple it to the back. Okay, I'm going to go ahead and get started and pick up where most of the classes left off. So I'm going to start with the reading here, where it says difference between mass and weight, because I think in all of our classes we had already talked about the puppy and the bowling ball. Okay, and so I'll begin reading here, which means I'll begin answering questions from, let's see, it's page 12. We're not in section 2 yet. All right, so the last question we answered was 13 in most classes. If you already answered question 13, good, because I'm going to pick up with, not this page, because what should be next is page 13, I believe. So page 13 is where we're going to pick up from. Yep. So this is where I'm starting with the questions, which should be the page that you just got from Mr. Weimer by now. Okay. If you haven't, pause the video, get this page, staple it to the back of the question packet. I'm going to be starting here, which is page 13, which is an add-on. Here we go. That was it. Here we go. Okay, so the difference between mass and weight. And the first question says, there we go. All right, what does all matter? Oh, why does all matter experience gravity? Okay, so that's the answer that we're looking for. The difference between mass and weight. All right, weight is different from mass. To understand the difference, you must first understand gravity. Gravity is a force of attraction between an object that is due to their masses. The attraction causes objects to exert a pull on other objects. Because all matter has mass, all matter experiences gravity. The amount of attraction between objects depends on two things: the masses of the objects and the distance between them, as shown in figure 5. Okay, so figure 5, what's going on in figure 5? Ew. Okay, so figure 5, how mass and distance affect gravity between objects. Gravitational force represents the width of the arrows. So the width of these arrows is pretty thick, right? Is larger between objects with large masses that are close together. So basically, the larger the object, the more mass it has, and the closer it is to another object that's also very large, the more mass it has, your gravitational force is going to be stronger. Okay? By the way, gravitational force is a fancy way of saying weight. Gravitational force is smaller between objects with smaller masses that are close together than between objects with large masses that are close together, as shown in A. So smaller mass, less gravitational force, even though they're about the same distance apart. The more mass you have, the more gravitational force you have. So basically, the bigger you are, the more you weigh. So let's think about that. Think about you compared to me. Who's going to have more gravitational force? Remember, that's a fancy way of saying weight. All right. Okay, stop laughing. I think you get the idea. Moving on. All right. So part C. An increase in distance, see how much farther apart these two objects are, reduces gravitational force between two objects. This is us and the moon. Think about it that way. You knew that. You don't have any gravitational force, right, in space. You don't have any weight in space because the further distance the two objects are, the gravitational force, weight, is reduced. Therefore, gravitational force between objects with large masses, such as those in A, is less if they are farther apart. So the closer you are, two objects are that are with large masses especially, the bigger the gravitational force, which is the weight. Two objects that are still large in mass, but the farther apart they are, less gravitational force. This is us versus being in space. Basically the same thing, okay? So I think we can answer our question now. Let's see. Number 14, why do all matter experience gravity? Okay, all matter has volume, or is it all matter has mass? All matter is constant, or all matter is stable? Let's go back to that first part of the paragraph. Weight is different from mass. To understand this difference, you must first understand gravity. Gravity is a force of attraction between objects that is due to their masses. The attraction causes objects to exert a pull on other objects. Because all matter has mass, all matter experiences gravity. Ding! I think we just answered our question. So for this one, why does all matter experience gravity? Ding! All matter has mass. All right, look at figure 6 on page 39. As two objects get blank, it's either close together or farther apart. The force of gravitational between them, the force of gravity between them increases. Let's read it again. So it's going to be, as two objects get closer together, the force of gravity between them increases, or should it read, as two objects get farther apart, the force of gravity between them increases. Going back and taking a look at your picture, right? Let's take a look at what we have here. Okay, look at this. Where's the gravitational force bigger? Basically, where are the thicker arrows? And those arrows are thicker when you have two gravitational objects that are closer together. See that? As opposed to being farther apart. So for this question, I think we got it now. We should have farther apart. You can write it in or you can circle it. Completely up to you. All right, next one. All right, true or false? Weight is a measure of the gravitational force exerted on an object. True or false? True. Okay, so if you want to know how much somebody weighs, don't flat out ask. Gentlemen, especially later in life when you get married, and you might be wondering how much your wife weighs. Don't say, hey babe, how much do you weigh? No. Use some fancy science words. Be like, hey honey, you're looking pretty good. What's your gravitational force? Another way of saying weight. Oh yeah. You're welcome. All right, going on to the next part. So number 17, a brick weighs less in space than it does on Earth. Why? Let's go back to the reading for that. Here we go. Here's our brick and a sponge. May the force be with you. Okay. Gravitational force is experienced by all objects in the universe all the time, but the ordinary objects you see every day have masses so small, relatively to say planets, that their attraction towards each other is hard to detect. Therefore, the gravitational force experienced by objects with small masses is very slight. So this is saying the smaller mass something has, like the mouse that I'm using, right? The less you're going to notice the gravitational force, okay? So again, therefore, the gravitational force experienced by objects with small masses is very slight. However, the Earth's mass is so large that the gravitational force between objects, such as our atmosphere or the space shuttle and the Earth, is great. Gravitational force is what keeps you and everything else on Earth from floating into space. So our gravitational force, or weight, is what keeps us from floating into space. So what about weight? A measure of the gravitational force exerted on an object is called weight, as we just answered. Consider the brick in figure 7. Ta-da! The brick has mass. The Earth also has mass. Therefore, the brick and the Earth are attracted to each other. Not that kind of attraction. Gravitational force kind of attraction. Stop smirking. I see you. A force is exerted on the brick because of its attraction to the Earth. The weight of the brick is a measure of this gravitational force. Now look at the sponge in figure 7. The sponge is the same size as the brick, but its mass is much less. Therefore, the sponge's attraction toward the earth is not as great, and the gravitational force on the sponge is not as great. Thus, the weight of the sponge is less than the weight of the brick. So this is basically saying, I'll read here where it says figure 7, this brick and sponge may be the same size, but their masses, and therefore their weights, are quite different. Same size, different mass, different weight. So which one has more gravitational force, more weight? The brick. I think we can answer the next question here. Let's see. A brick weighs less in space than it does on Earth. Why? Let's make it simple. And we'll say because it has more gravitational force. Oh, a brick weighs less in space than it does on Earth. Oh, that's because there's less gravitational force in space. There's less gravitational force in space. And we'll leave that one like this. And then if you answer this, also you'll realize that the answer could go a little bit longer. It's like there's less gravitational force in space compared to being on Earth. So from Earth to space, less gravitational force. That's why we would float if you were in space. The farther apart you are from the Earth, the less gravitational force you have. Therefore, you would float. Okay, so write this down. Pause if you need to, because now going away. Moving on to the next question. That didn't work. There we go. Why do people tend to confuse the terms mass and weight? Oh yes, mass is not the same thing as weight. Okay, so if you haven't figured that out, but mass is not the same thing as weight. Okay, remember weight is the actual gravitational force, the force that keeps you on Earth. Okay, mass is how much stuff there is of you, which is different. Think about it that way. So the gravitational force is your weight. Mass is how much stuff there is of you. Okay. So we'll get this answer much clearer through this paragraph that's called massive confusion. Back on Earth, the gravitational force exerted on an object is about the same everywhere. So an object's weight is also about the same everywhere. Because mass and weight remain constant everywhere on Earth, the term mass and weight are often used as though they mean the same thing. But using the terms interchangeably can lead to confusion. So remember, weight depends on mass. Weight depends on mass. But weight is not the same thing as mass. Okay? So I think we can answer this question right here. All right. So why do people tend to confuse the terms mass and weight? Both remain constant on Earth is the answer for this one. I don't even have to read the rest of them. People use the terms interchangeably. Actually, they do. Oh, there's more than one answer. That's why it says circle all that apply. Mass is the same thing as weight. Well, it is not. Mass is also dependent on gravity. Okay. So mass is also dependent on gravity. That sounds like it might be it. Let's read again. Back on Earth, the gravitational force exerted on an object is about the same everywhere. So an object's weight is also about the same everywhere. Because mass and weight remain constant everywhere on Earth, the term mass and weight are often used as though they mean the same thing. But using terms interchangeably can lead to confusion. So remember, weight depends on mass. But weight is not the same thing as mass. Let's go back. Can we circle that last one? Mass is dependent on gravity. No, we cannot. Okay? So the ones we circled are the ones that are going to be it. Okay, so measuring mass and weight is the next part, which will be starting from right here. And I'm going to stop this video because I can only record 15 minutes at a time for free without actually having to buy the program. So this is the end of part 1 of your work. And then so go ahead and click part 2 and we'll start right here.